Greetings, all y'all in Mathland. Today I want to show you a new or alternate method to solve quadratics. This is recently put out by Po-Shen Loh of Carnegie Mellon fame, and it's a very interesting new method. So let's take a moment to see what we can do. Let's start with one problem that isn't too crazy. So let's first look at how one might solve this by factoring. Well, I teach a method called Snowflake, and the way that I do this is you look at A times C, which is 24, and that goes on the top up here. B goes on the bottom. B being 10 goes on the bottom. And then I just take the leading coefficient there, and the x, or whatever variable we're dealing with, goes in the wings here. And now what we do is, true to all factoring, we kind of guess and check here. We find the factors of 24 that sum to 10. So it might take a little bit of guess and checking. So factors of 24 that sum to 10. Well, 24 and 1 do not work. They sum to 25. So let's try 12 and 2. Nope, those add to 14. 8 and 3 do not work because that adds to 11. And as we see, 6 and 4 do work. 6 and 4 do work. So from here, we now have my factors. We know that x plus 6 and x plus 4 are the factors. So I'll just go ahead and write that in factored form over here. Equals 0. And now using the zero product property, each one of the factors sum to 0, like so. And then we get x is negative 4, and the other solution is x is negative 6. Now, graphically speaking, what does that look like? So let's look. When we graph this function, we see that my two solutions are the x-intercepts. I'm going to call this one r and call this one s. Now, notice another thing here, that the vertex is right here. The axis of symmetry is the vertical line that passes directly through the vertex, like so. And a key thing to notice here is that the distance from R to the axis of symmetry is the same distance as from S to the axis of symmetry. So I'm going to call this value right here, I'm going to call this one x bar, because it's the average of R and S. So in our situation here, we have a negative 6 here as one of the solutions, negative 4 is one of the solutions, and the average here is negative 5, directly in the middle, the midpoint. So how did we find x bar? We found x bar using this little negative b over 2a. That's to find the axis of symmetry. So let's go ahead and do that right here. So we know that a is 1, and we know that b is 10. So let's plug that in and see what we get. So x bar is equal to negative 10 over 2 times 1. And when we clean that up, we end up getting a negative 5. Makes perfect sense because we had negative 5 right here. It's the midpoint right there. Now here's the key about this new method. And you don't have to replicate all this. We'll jump to it in just a moment. But to understand it, let's notice here. This distance right here from R to x bar, we'll call u, is the same as this distance right here from x bar to s. We'll call that one u. So when we subtract u from x bar, we get to here. When we add u to x bar, we get to here. So let's see how that works out. R is equal to x bar minus u, and s is equal to x bar plus u. Now, r times u is going to equal r times s is going to equal what we had before, the 24. So what we can do is substitute some things in, and we always get nice A nice result here. So x bar minus u times x bar plus u is equal to 24. And here's a nice thing. These two right here are conjugates. So when we multiply them, essentially we get squares. So all we have is x bar squared minus u squared is equal to that value over there of c. Now we already know what x bar is. In this case, it's -5. So I'm going to plug -5 in right here. Squared minus u squared is equal to 24. Now this is the key thing right here. This one right here, whatever my c value is, this is going to be my generic formula that I'm going to use, because we already know that these two up here are going to simplify always. We have a product of conjugates, so they're always going to be a difference of 2 squares. So now finishing this one up here, we've got 25 minus u squared is equal to 24. Now subtract 25 from both sides to get u squared is equal to -1. Forgot that negative. Take the opposite of both sides to get a 1, and take the square root right there, and u is equal to plus or minus 1. So it doesn't matter if it's plus or minus. So now let's bring that up here. In this situation, we have -5 minus or plus 1. Let's go with, minus a 1. And over here, we have -5 minus a -1. And it actually doesn't matter which one you call R and which one you call S. Ultimately, what happens is that one of them is going to, they're both going to simplify. So this one here gives me a -6, and this one here gives me double negative, there's positive, so that gives me a -4, which is exactly what we expected right here. Now, what we didn't expect is I labeled R and S over here, but they actually switched places the way I did that. And it doesn't actually matter, because R and S are interchangeable in a sense because of the axis of symmetry. That doesn't matter which way, if you add or subtract, you're going to end up with one or the other. So we're just going to generically call this one R, generically call that one S, but they can be switched around. Okay. So let's go ahead and do another problem like this, but starting rather with this guy right here, calling that one C. So let's look at this one here. We have x squared minus 6x minus 72 equals 0. So we know that generically, this is what's going to happen. That x squared, the x bar squared, the average, minus u squared is going to be 72. So let's find out what x bar is first. Again, -b over 2a. And so we say the opposite of b, here's b is -6, over 2 times 1. Clean that one up, double negative is positive, we end up with a 3. So now we have the x bar squared minus u squared is equal to the -72. So we bring the 3 over, 3 squared minus u squared is equal to -72. Keep working this through in order to find out what u is, the distance from the average. And we get -72 stays the same, -u squared is equal to, and we get -81. Take the opposite of both sides, and take the square root of both sides to get plus or minus 9. So again, our R value is going to be x bar minus u, and the S value is going to be x bar plus u. So when we substitute in, we have a 3 minus 9 and a 3 plus 9. So here we get a -6, and here we get a positive 12. Now let's check with graphing. So let's check our graph here. Here we have our function, and here we have -6 and positive 12. -6 and positive 12. And there we go. So let's review our new method to solve quadratics. Number one, we need to find the axis of symmetry value, because that is what we're going to be calling our x bar. So x bar is equal to the opposite of b over 2a. Number two, now we're going to take x bar and we're going to subtract u squared is equal to whatever the value of c is. And I do want to put a caveat here on this c. Make sure that when we write our equation in standard form, that the a value is 1. So you might need to divide by a before you finish up and start solving it this way. Okay, so step number 3 is we isolate the u, and then we substitute into what we had with the r is equal to x bar plus u, and then s is equal to the x bar minus u. And of course we're going to check. And there we go. Have fun with this new method.